There you go. So I'm just gonna record it so people can have it in case they don't get to participate. But anyway, so let me get started with a few things. Hi everybody, as you coming in. I hope everybody's doing well. I hope that you are keeping yourself safe and keeping your distances for essential stuff. I mean, like any of us who kind of understood what was going on here, we saw that, we're not even close to the worst part yet. And we're going to start seeing people dying, and we already seen a lot of that. And United States right now is the worst in the world in terms of that. And you know, it kind of made me upset that I wish our leaders will do a little bit better on this. But maybe we have a good government that is taking care of things. And we already seen results. We actually already seen that California is what they call flattening the curve. Does everybody understand what that means when they say flatten the curve? It's basically a statistical curve. So when they go out, people were not distancing themselves, the cases go up. And so as soon as people start social distancing and all that, following all the regulations, then the curve starts flying out. That means that there's no longer as many cases. The cases go down. So California is doing very well with that, but this is one of those things that does not respect state boundaries, and it's going to be, like I say, it's about regulation. We haven't seen the worst yet. As far as when it comes to the class, we are, as you know, most of you probably already know this, that we are going to continue through this at the end of the semester. In fact, they're looking at the summer, so soon they're going to start opening up registration for summer. All summer classes, even if we're scheduled to be face-to-face, are going to be online. And again, we don't know how long it's going to go. It could be as they begin to open up the fall. It may also be that all classes open to be online to the fall. So we don't know that yet. As far as we know, we are on these through the end of the semester. So basically, we're gonna try and take the best out of the situation, as I indicated before. Let me. I made some adjustments to the schedule. As we pretty much needed to do because we try to get out of one of these folders over here that are set up. So we're gonna have to make some adjustments on the schedule, just simply because the way things are. I have to make some adjustments. So let me show you what. Get out of these one screen that okay, there we go. So let me show you what I've done with the schedule. Let me create a new share and go over to this screen over here. All right. So now you should be able to see. Does anybody see the revision schedule? So just say it on the chat, or again, by this time, hopefully you guys are becoming familiar with the features. I mean, I've been training pretty much every day, trying to find different ways to do things and everything. But do people see the? You can nod, or you can say something on the chat. Do you guys see the schedule revision?
Yes.
Yes.
That's what should be on the screen right now, isn't it? Yes? Or maybe not. There we go. How about now?
See it. Okay. Yeah, I see it now.
So this is already been posted on Canvas as well. And what you see again, substantial revisions have been made. I'm going to start out with atmospheric moisture movement, which is chapter 6, and all that stuff. Remember that there are two to do this weekend. The map quiz number 4 for all that's going to be doing Saturday, and the photo essay. So hold on for questions for photo essay. I'm going to tell you how we're going to handle that. All right. As you can see, going through the schedule, I've actually taken out one full. As much as I hated to do this, but run out of time. So I took chapter 10 and 11 out. We're not going to cover that. And so as you can see, like I say, things are not changing. I mean, you guys have been sending assignments on that's not changing. Like I said, I want to explain a little bit of what we're going to do with the essay simply because people cannot go out now, cannot go out and take pictures. So I'm going to explain what we're going to have to do in that situation. So again, look at the schedule. I moved a few things up. For instance, the key concepts, they're still going to be due. I mean, you still, just like you did before, you have to complete them, you have to answer the questions, and you have to submit them on Canvas. The date has been moved on about 2 weeks, I believe. So it's not going to be due on the 26th of April. But they still have to be done. Some people have asked me, yes, we're still doing that. You still have to do it. You want to get the points, you need to do it. Right? Now, because I took chapters out, I took chapters 10 and 11 out, you notice that the last set of key concepts, in fact, the last exam, is going to be chapters 13 and 14 only. But I am still going to give you the points that I would have given you. I think it was like 50 or something like that. Whatever points, if you submit, if you do the chapters that I do on the last one, on the last set of key concepts, you're going to get the full points. Right? Now I also move up the exams. Right? The exams are now going to be done online. Right? And so next week or 2 weeks after, 2 or 3 weeks, basically the same way that I usually done a test prep, I'm going to explain how the exam is going to be set up. It's going to be done all online. And there's going to be, again, I'm going to give you the specifics about it. I'm still going to go over people questions, that kind of stuff, but you're going to do it online. Just like you do the map quizzes, it'll be a very similar thing, time constraint and everything. There's a bunch of tools that are going to prevent people from sharing answers with each other, right? They're all basically random anyway. But it's going to be done online. So there's going to be a deadline, usually on a Sunday. The first exam number 2, which is the first one we're doing online, chapter 5 through 9. Remember that we didn't really hardly cover chapter 5 in the last exam. So we chapter 5 through 9. So basically the same deal is you submit it, you have to submit it by May 3rd by 11:59 p.m. And so again, same thing. It will be the same thing as we done before. But it's going to be longer. It's an exam. Like I say, I explained some of the details. Not much different than what we've done on online, on face-to-face, except that because there's not going to be Scantron, none of that stuff. But it will be an exam just like still be worth 150 points, but it would just be done a little differently, all online.
Cool.
So again, look at the schedule. Like I said, this is posted on Canvas as well. I just posted it on the current module. I'm going to take that in a few minutes here. So again, look at the deadlines. Again, this is really important because if you are not looking at the new schedule, you're going to be confused. And then you're going to say, oh, I didn't know, or you said it was going to be at that time. That's why I made this up. Now, I also noticed that I took one of the photo essays out. Right? So instead of doing 5, you're going to do 4. Photo essay number 4, that is going to be sometime in May. That's going to be double points. Instead of being worth 30 points, that's going to be worth 60 points. So again, you give your planner heads up about that photo essay. So make sure you get those 60 points. Otherwise, you lose 60 points if you don't do it. Like many of you haven't done it yet. Anyway, so we still have those video, the video review. I think the date, I think it was left the same. So again, those of you who want to do that, want to get that extra credit, you need to submit that to right? But again, take a look at the schedule. I'm not going to go over all the details. I just want to highlight a few things on it. Take a look at it, and like to say, keep it up because it's been changed drastically from what we had before. A lot of stuff I've been taking out, and some days move that simply because of what we have. Right?
I
So
have a
again,
question.
this weekend, map quiz number 4. Some of you already done it, and photo essay number 3. Now here's the deal with the photo essay. All right. Everything remains the same in terms of what you submit. Right. The format is the same. So for photo essay number 3, the only difference is that because you are not allowed to go outside, you can go out and take pictures. The difference is that I'm gonna allow you to take other pictures. If you have all the pictures, you can use them still. If you have already taken some, want to use them, that's fine. But you can find pictures on the web, right? And you're gonna have to still do the same thing. So let's say you find a picture of snow somewhere, whatever, right? Just an example. You're gonna have to explain the concept in the first paragraph, just like you done if you took the picture yourself, right? The difference, of course, here is when you're looking at the template and you are telling me when you took the picture and all that, you have to tell me where it came from. Just like a simple reference, National Geographic, data such and such, right? So because it's not your picture, you have to tell me where you got it. Simple as that. Just in the spot that says, where was the picture taken and all that, you have to give me details about that. The rules about the concept still remain the same. How to find legitimate physical geography concept. Look at the list. Those list of concepts are still left out on the module. Go to your textbook and find the definition. Now you shouldn't have any excuse now when I don't have a textbook. Well, go get it online. It's free now. I told you guys last week that the week before we left that now those the digital version of the textbook it can be made available to you for free. So there really should be no excuse for you guys not to use the textbook information. Again, the only difference on this whole thing is that you can use pictures were not necessarily taken by you. They still have to represent the concept. Second paragraph, you still have to tell me how is that picture that you put in there, how did that picture represent the concept? Remember, the first paragraph is about the concept. What is this? You're talking about snow, define it. Give me a definition, explain the concept. Whole paragraph talking about that concept, right? Second paragraph, now you tell me, okay, I found this picture on National Geographic. I thought it was a good representation of precipitation, or I thought it was a good representation of volcanic activity, whatever, plate tectonics, okay? So the rules are still the same. The only difference is you're not taking the picture. Does not make any sense. You can chat and say, "Oh, I don't understand." Put it on the chat and says, that's not clear. Does anybody not understand what I just said? Again, if you have your mic mute, you can unmute it and ask or whatever. Okay? Anybody not clear what I just said?
I was going to ask about the photos, but just answer my question.
Okay. Yeah, that's what I say. The only thing that changes on this assignment is the fact that because you cannot go outside and take pictures, pictures, but you still defining the concept. You don't follow the same rules about paragraph, except the pictures do not have to be yours. If the other is fine, if you took them or you had them. Now here's the other thing. That some of you have had pictures from when you went to Cancun last year, last winter, summer, whatever. That rule has changed now. In the past, it had to be taken in the semester. Now, okay, I took something a while ago. So you can use pictures that are not necessarily from this semester, or you can take and find something on the internet that defines the concept.
Cool. Okay. Thank you.
Okay. Again, remember, so there's only going to be 4 now instead of 5. The last one, particularly important, is going to be worth 60 points. It's going to be worth double the points that they usually worth. So, not very carefully. right? What you see on the screen now is I'm looking at basically how it looks like for you. So you can look at the modules. I still haven't quite updated all of them, but I'm moving stuff around in terms of making it whatever we cover in that week. Uh, but just to review, if you know what I'm pointing at right now, that is the lecture that we have on the 20th of March for you guys want to replay. And I will do the same. Right now I'm recording this one. I will do the same next. I'm going to post it on the modules as soon as we finish the lecture. Right. So here's where we're going to be at for this week. By the way, also again, that's also the link for free ebook. So again, if you don't have the book, if you never bought it, I don't understand why, but you know, it's free now. You should have no excuse, and you know, I want to make sure that everybody uses it when they're defining things, and of course,
No.
okay. All right. So the last thing, so again, this is all I put the revision of the calendar in there right now. Again, you can look at that. You can take a look at it, and make sure you keep it around so you know what the deadlines are. All right. Any final things about where we are with everything?
Yes.
Okay. All right. So so let me any final questions before we move on? I'm gonna go ahead and start with atmospheric moisture. Everybody good? So again, remember that you guys can mute or unmute yourself as you need it. So if it's too noisy sometimes, I can probably take I can mute everybody. Right? I know that some of you are saying that you hear noises in the back. It's people that are not muting themselves, and people hear that. Right? And I know you are hiding yourselves, you're not showing your faces, but that's okay. We're gonna have to maybe deal with that later. It's okay not to show your faces, but remember, you still need to participate on this stuff, right? Okay, so let me then go ahead and go over to start the lecture. Any final questions before I move on?
No, it's pretty much, we're good, I guess.
I'm sorry?
Good.
Okay, let me move on to then to start chapter 6. Everybody do you guys see that now on the screen?
Yes.
Do you see chapter 6? Oh, let me see. All right, do you guys see that now?
Yes.
Okay, so anyway, so all right, so let me go ahead and start with that. The usual, we're gonna let me show you some of the key questions about this chapter. So we're gonna look at water, the influence that water has and the effects in the atmosphere. We're gonna talk about latent heat, very important concept in this whole process of precipitation and atmospheric moisture. We're gonna understand relative humidity. We're gonna understand why that is important. Why does it changes? We can look at, remember we talk about in pressure, I know it seems like it was a long time ago, but when we talk about rising air, usually in a low pressure system, we're gonna see why it is important that warm air, because warm air always rises. Why is it so important that that warm air that is rising, why is it so important in climate and elevation, precipitation? We can look at the factors responsible for areas in the world that are wet, and you know, in areas that are dry. From what we talked about before, we noticed that even just pressure systems, we can see in some regions simply because they're not a system area, they're going to be wetter. In areas that are in high pressure system, they tend to be relatively dry areas. So here's a quick outline here. We can talk about water, some of the properties of water. The changes, the phase changes, the physical changes of water are really important in this process. Water vapor and evaporation, why is that so important in precipitation? Humidity, why is it important to understand it? The whole concept of condensation, which is how clouds are created. They are about a process, the process that actually leads to creation of clouds and eventually to rain. And of course, clouds. So those of you who are going to be doing they're going to be doing a photo essay, and you know one of your concepts is going to be cloud. Clouds are not acceptable anymore. Right? Just telling me clouds is not acceptable. You're going to understand the difference, the different families of clouds, the different types of clouds. So again, if you use clouds as a picture for your concept, that's too general. I'm not going to accept it. You're going to get knocked down and pay points for that. You have to tell me which clouds they are. You're going to understand that today. We're going to understand the whole concept of atmospheric stability. Why is it that unstable air usually leads to cloud formation and precipitation? And even later, in the next chapter, we're going to talk about disturbances. It can lead to actual, storms, thunderstorms, hurricanes, tornadoes, and so on. And of course, we're going to learn about different forms of precipitation. And then we're going to understand the processes that cause air to rise. And the requirement for clouds to be formed. Certain processes lead to air being lifted, that it can lead to precipitation. And then towards the end, we're going to look at all the different how rain, precipitation is distributed around the world. Okay, let's look at the picture right now. And if you want to answer, you can chat something. You can put something in the chat, or again, you can unmute yourself and very quickly tell me. You see water? You can type. Again, if you're awake out there, I see people that they have their mute and everything, but where's water?
Everywhere, pretty much.
So let me see. Let me put the arrow over here. Is the water here?
Yes.
Yes. There's water there. About here, is there water there?
Solid, yes.
So that's frozen water, right? That's a glacier. That's an iceberg, right? Is there water up in the hills? Yes. There's water up in there's snow up on the snow on the mountains. There's water up there, frozen water as well. And what else is there? Is there water? You see some
atmosphere, maybe?
Place? It's an atmosphere. There's water vapor floating up in the atmosphere. Right? And that's again, we talked about this briefly before. That a big source of water in the world is actually the water that we have up in the atmosphere, water vapor. So we can find it frozen, and this is what we call the different states, physical states of water. This is one of the very few substances in the world that we can find in all physical states. You can find it frozen, solid. You can find it liquid, like we see, like we're known. Again, solid, both in the top of the mountain and on the glaciers, and we can find it as a vapor, water vapor. All right. Now here's the deal about water. Water is all over the place, commonplace, but it's very very scarce. Let's put it that way. Well, now let me requalify that. We have water all over the place, right? And in fact, 70% of all surface of the planet is water. If you look at the globe, you can see that the blue, right, is oceans. So then 70% on the entire surface of the globe is water. If you look at the distribution, you can see down at the bottom when I is pointing at. Most of the water, however, is salt water, salty. 97.5% of all the water that we have in the world is salty. Nothing we can do with it. You can't use it. I mean, we'll talk later about particularly in chapter 9, when we talk about the hydrotreating, we'll see how people are now taking advantage of all that salt water and desalinizing it and making it fresh. But look at this, 2.5%, the rest of the water is actually fresh. Is stuff that we can actually do. So you can see, even though while there's water all over the world, very little of it can be used. Right? It is 2.5% is fresh water. You go down for all the fresh water, that 2.5% of that fresh water that we have, about 70% of it is actually frozen. It's in glaciers. It's going to be on top of the mountains, right? And you can see now why that is so important, because that water staying up there frozen, it remains, and eventually when it melts, it's going to become liquid water in fresh water, rivers, into lakes and stuff like that. And again, we'll see the connection. That's why we care. Right now, we are looking at the Sierra Nevada up here in California. We always look at what they call the snowpack. You know, we've had a lot of this year, this season, but we care more about what is up there. Right now, they're saying something about 60%. It's at 60% of the level it should be. So we're actually below the level we should be. And that's why we care about it, because that water eventually is going to, some of it is going to melt, and it's going to go into rivers. It's going to give us fresh water. 30.1% of the water that is fresh around the world is actually underground. It's groundwater. In chapter 9, we explain how that works. Where that water come from. Okay, we'll understand that later. And the other percent is about 0.8% of it is permafrost. Places around the Arctic Circle and the high latitudes, Russia, for instance, lots of Nordic places in Switzerland, Sweden, Finland, all those areas, they have frozen ground. Remember that there's a certain amount of moisture in all the soil. In those areas where it's all the time, where it's really cold, some of that water is frozen. So we have a lot of fresh water there. All right, and 0.4%, very small amount, is actually up in the atmosphere. Remember that now, and as well as in the surface. So the places that we're showing, for instance, the water that is actually fresh in a lake, on a river, or in the atmosphere, is very small as well. 0.4% of that water is surface and atmosphere. Now you can see when you look at how the surface water is broken down, we see that 67% is in freshwater lakes. Not all lakes are water. We'll see that some of the in fact, the largest lake in the world is actually salty. Right? We'll see that rivers only make up about 1.6% of the water in the world. It sounds impossible when you think about the Amazon and stuff like that. Iota is the water that you find on leaves and anything that is living, right? It's going to have a certain amount of water. All trees, all plants have water. That's what is called the biota. And wetlands. It's a lot of wetlands that usually we have rivers as they go into the ocean. Before they go into the ocean, they create wetlands. We have wetlands in different areas of the world. And those are, in most cases, also fresh water. Even the ones that we have here, when you have that river that comes up from Chula Vista into the ocean, that wetlands that are usually fresh. They actually are the boundary between the ocean water, where it's actually the water is going to end up, and then the water from the ground, And again, maybe with the moisture, there's always moisture on the ocean. If it's not frozen, it's about 12.6%. And the atmosphere of the fresh water that we were talking about is 9.5%. So look at it this way. So 0.4% is surface atmospheric water, right? Very small amount. From all the water that we have, out of that 0.4%, right, 9.5% of that 0.4 is actually water vapor. Is the stuff that we have up in the air. So we can see that the amount of what is called atmospheric moisture that we have is 0.00095%, not even 1% of all the entire world water, the fresh water that we have in the world that can be used for people to drink and all that, is water vapor. But that water vapor is extremely important, right? It is extremely important. It is water that people live on. And you can see how precious that water is, because that's the water that eventually going to give it rain. You know, fill in the the glaciers, it's going to create the glaciers, it's going to fill it, continue to fill in lakes, the rivers, and so on. Right? So that's the one I'll be talking about in the next through this whole chapter. All right. Questions about that?
No.
All right. So let's talk a little bit about water. Water is, like I said, we find it in many different places. I'm not gonna. So basically, water basically is not infinite. Water is not constant. Let me put it this way. Finite is the opposite of infinite. It's not going to always be available, right? In many places around the world, I'm finding that that supply is diminishing. It's becoming less and less, becoming very scarce. It's also not constant, meaning that is water that is not distributed equally. It's places that are very dry, and it's places that they have a lot of water. And so it's not like it's okay, yeah, we're gonna sort of distribute around the world. Everybody has it. It's not like that. And again, it's becoming one of the most commodities that we have. It's already probably in some places in the world more expensive than oil. Just think about it. I mean, think about how much one of those little bottles of water costs you, and figure it out. If you pay what nowadays about $3 for a gallon of gas. Well, you're paying $2 for one of those little bottles, So you can see where this is at, and in fact, it's becoming more scarce. It's going to become many places already a problem. As the planet gets warmer, it's going to become more in many areas of the world. Now, here's the deal with water. Like I indicated earlier, water is one of the very few substances that you can find it in all physical states. Solid, liquid, and gas in nature. Not all substances do that. You find gold as a liquid. You don't find it flowing around somewhere. Right? It always only found solid. You do stuff with it once you found it. Other substances, other chemicals are liquid, are found only liquid, and so on. But water is one of those. You can find it in those three main physical states. Now, over to the right, you see the hydrologic cycle. Like I said, I'm going to explain more detail about that on chapter 9, when we fully focus on water, on just water on the surface and everything. But basically, you can see that water circulates. It rains. Some of that water fills in lakes, rivers, water that obviously in the mountain through adiabatic processes, orographic processes. It creates clouds, creates rain. That water eventually runs down into the rivers, those rivers fill in lakes, feed into. And most of that eventually is going to end up in the ocean. That's about most of the major rivers in the world eventually end up in the ocean. If you ever wonder why is it that water, the ocean is salty, is because over millions and millions and millions of years, all that runoff coming in from the ground eventually ends up in the ocean, bringing all these minerals, bringing all this stuff that makes it saltier and saltier as time moves on. Again, and this has been happening for millions and millions of years. Over that period of time, the oceans have become salty. That's the same reason why some of the major that we have in the world are becoming saltier as well. Because again, we're talking geologic time here, but some of these lakes are also becoming saltier and saltier. Because you can see that process. Water moves around. Atmosphere runs over into the ground, eventually ends up in the ocean. Some water, the process that we're going to explain here is the process that happens on land, which is the one that we care about the most. But there's also water that goes up into the atmosphere to evaporation in the ocean. That's what I'm going that way. But most of the processes on land are created process that we're going to explain here, the adiabatic process. I still hear that some people don't have their, let me see. Anyway, okay. All right, so here's the deal. So again, water is found in all forms. right? But it's changing. It changes all the time. Is water that is liquid can get frozen, can become solid. Water that is in vapor, through condensation, it can create clouds and eventually become liquid and rain. And then that water, there was gas, can then be liquid floating around, right? So, and water goes from liquid, one of the states being a liquid state, when it goes from liquid to gas, that's called evaporation, right? You see a screen down here at the bottom that shows you what happened every time. And here's something we have to, like one of those laws that we have to remember. Every time I tell you something very specific, it's something you have to remember. Every time that water changes states, they say when it goes from, you see on the picture, you see a triangle at the bottom here. When water goes from liquid to solid, right? Water is going to, energy is either going to be released or absorbed. So when water goes from water to ice, you actually release heat, right? When water goes from ice to water vapor, which is called sublimation, you absorb heat. When water goes from vapor to liquid, heat gets released as well. So again, every time that water is changing, either sometime energy is going to be released, heat is going to be released, or heat is going to be absorbed. So in the case of evaporation, is when water that is liquid becomes a gas. Same thing happens when you put water on the stove and start boiling. All that stuff that looks like smoke is coming out. That's actually now water that has been converted into a gas. Condensation is when gas, now I'm pointing out the most important ones here, the ones that can relate to nature. When gas goes to a liquid, that's called condensation. That's what usually happens when we have water vapor, like the one that we have up in the atmosphere, moisture that we have up in the atmosphere. When that water changes from vapor into liquid, which is what happens when clouds are created. And I'm gonna tell you for the first time, I'm gonna repeat it a few more times. Clouds are not gas anymore. They're no longer water gas. They're not water vapor anymore. They now have become liquid. Tiny little particles, but they're liquid. So the process of condensation is extremely important because water vapor that is up in a gaseous state, the physical state of a gas, is converted to liquid. When that happens, if you look at the little triangle at the bottom, when condensation happens, heat gets released. That's also really important to remember that. I'm not talking too much about evapotranspiration. That's usually what happens when we have, it happens on the plants, it happens on the biota, is water vapor that enters the air from the ground. So if you have, let's say, you have a canal full of water, the days gets hot, they're going to start evapotranspirating. I mean, that is going to be creating vapor out of that water. But plants are doing the same. Plants also, when they do all their processes, they also release water. And usually as a gas, they release it up in the atmosphere. When you look at the hydraulic cycle, hydrologic cycle, also called the water cycle, when precipitation is greater than evapotranspiration, that means you accumulate water on the ground. Again, you see it like when it's happening right here, and when the amount that is, let's say you have a big rain, and some of the water starts moving around, it's going to be running off somewhere. All that water that is left over after evapotranspiration is going to go into the lakes and stuff like that. Right? So now, the two main ones that I focus on is evaporation and condensation, because these are the ones that we deal with in the planet that leads to eventually rain and stuff like that. So far, so good. So remember those two. And I'm going to go back a little more when we start talking about condensation and see the effect of that extra heat that results from that process, what happens to that heat. So now, before also we go into understanding, what is happening with water, let's understand some properties of water. Why they're so important. Again, I mentioned that is one of the few substances in the world, natural substances that are actually found in all states, in all physical states. Here are some properties that are really important to understand water. Water has liquidity. You can find liquid water all over the world. And if you don't believe this, I mean, you can go to Antarctica, and especially now that we're starting to have high levels of heat, temperatures higher than normal out there. You find running water in the Arctic, where basically everything around it is frozen. But you can find water, liquid water, pretty much anywhere in the world. Now, so liquidity, that whole concept of liquidity, and it's extremely important function of water. And actually, by the way, this fact that it has liquidity, it also allows it to move around. So the liquidity allows it to run into rivers, fill in lakes, come down from the hills, fill in rivers. And so that liquidity, the fact that it can move around, is extremely important to having its presence all over the world. Another important property is that it expands. When water freezes, right, it becomes less dense. It's lighter, right? It loses a lot of its density. In other words, its weight, right? But it expands, but it gets bigger. Right? So that's why, for instance, if you see icebergs, right, an iceberg floats because it's usually denser. I mean, it's less dense than regular water, the liquid water. So it floats on the water because it's not as heavy as the liquid water is. Right? But it also gets bigger. All that ice basically expands, and when it freezes, loses its density, it loses its weight, but it expands. That concept is also really important when we understand. We're going to talk about it in chapter 13. We're going to talk about the fact that that property of water to expand, it also helps in the breaking up of rocks. We'll see that water gets in between the cracks of the rock, and when it expands, it breaks the rocks. And so a lot of these rocks, basically, you see, rock falls and stuff like that. And most of the cases is caused by water. The fact that water, when it freezes, it expands. Water also has what is called surface tension. The hydrogen molecule, H2O, is one of the strongest molecules there is, and one of the most stable molecules. Very difficult to break up. Right? Like sometimes you probably heard about people experimenting, trying to figure out how to make vehicles, for instance, run out with water. Well, the problem is that they cannot break that bond. If you're able to break it, it takes a huge amount of energy. If you're able to break it, you can create a lot of energy, and you can actually move cars and a bunch of it. But it's very difficult to do because it has a very strong bonding. The two hydrogen molecules get attached to the oxygen. It's an incredible strong bond. At the same time, because of that strength of that bond, right, the bond of the that water creates, it almost creates like a skin. I'll show you the little picture that you probably see right there. The little spider floating on top of water. And you can kind of see that it is creating like a skin. And of course, not everybody can walk on water, right? Who can or half they can. But it's a skin. It's a little skin that is created that is created by that hydrogen bond. It allows us to stay together, to stick together. That same really strong bond the water has, it also allows for capillarity. Capillarity is basically the process that allows for water, because again, with a very strong bond, to be able to pull itself around. That also what provides the liquidity. Water is being pulled around when it's in the rivers, but water can also lift things up, link those bonds up. So is the reason why water can go through rock cracks and end up somewhere in a lake somewhere, but it can also go up into roots. It can actually go into redwoods. All the water, the capillarity of water allows it for it to basically pull each other up all the way up to the top of the redwood. Right? Now, what you'll see here is one experiment that we can do to explain capillarity. And sometimes in class I do it. I bring these kind of stuff, but I used to do it in middle school a lot. Wow, kids, hey, look at this. So what you basically see here, you see water that is colored. It's been added some water, colorant or whatever they call it. And you can see that very rapidly. In fact, it takes seconds for, you can see that the water has been dyed as acquire a color. You can see like in the celery, it takes seconds for basically the molecules of water to pull the water up and take it all the way out to the leaves and change the color of the leaves. Again, that's basically a very important substance, a very property that water has, that it can pull those molecules up, take them all the way up. The same way that it does here with celery or with lettuce, like in this case, it can actually do the same thing going all the way up into the redwoods, taking water up there. So liquidity, expansion, the fact that it expands, tension, and capillarity are some very strong properties of water that allows it to basically be all over the place, and it gives it a lot of important qualities around the world. I mean, we need water. All living things need water, and so these properties allows it to be ever present, be commonplace all over the place, and allows it to move around. These functions, for instance, the capillarity, all those things also play an important role in how it works, how water works to create clouds, and so on. Like I explained in a minute. Any questions, any of those? You guys can chat, because I know that you still hear me, right?
Yes.
Yes,
Okay.
Yes.
we're here.
Type of question. By the way, you guys, and I put some. I gave you a lot of. There's a lot of workshops for you guys as well. Most of them, of course, have been done on Zoom nowadays, but they're always helpful because you always learn something. For instance, at the end of the class, typing out questions and all this stuff, you can create a log of all the questions that were asked. So type up your questions, and if I don't ask them right now, I'm going to pull down the log, and eventually I'm going to post it on Canvas, and I'm going to answer each of those questions that maybe I didn't have a chance to answer well, or we're talking I didn't see it, or whatever, right? So again, any question that pops up, a lot of times I know when you're in class, sometimes you're afraid to say it, or you can type it out, and I'll see it, and if I see it over here, I mean, I answer as we go along, but I can also answer them later on as well. Okay, so you get familiar with that chat, and again, everybody right now I have it set up for everybody, so make sure everybody sees them. A question that you may have is a question somebody else has. And like I say, in this situation, sometimes it's more effective than perhaps the mic. You can still use it, like I say, I have it set up so it can be only done one at a time, but use the chat so those questions can be written, and I can answer them later as well, or as we go along. All right.
Okay.
Okay. So talk a little bit more about this phase change in the water. Now what we're gonna do now is we're gonna see how these phase changes, and remember that we're talking about a phase change. I'm talking about the fact that water can change physical phase, physical states, right? You go from liquid to solid and so on. So let's see how those are manifested in nature. Now, and here's where an important concept, the concept of latent heat comes into play. This is heat that is basically up in the atmosphere, that it results from changes in the phases of water. Remember that when I show you the properties, the physical properties of water, when it's changing from vapor to water, or from a vapor to from liquid to vapor, heat is either being absorbed or being released. We usually call that latent heat. Now, so evaporation is a cooling process, which basically what happens is when an object gets warm, or water gets warm, it's going to start turning into a gas. It's going to start turning into water vapor. Evaporation is basically what happens when we as humans sweat. Right? When it gets too hot, our body reacts to that and begins to sweat. Sweating is basically our body evaporating, and is our body is using evaporation to cool us down. So sweat is basically a way that allows our body to cool down. Again, because we are processing, the body's getting a little too warm, the temperature that it wants, and automatically begins to sweat when it's past a certain point that it tolerates. And when that happens, again, the sweat that results from that is evaporation. That's what it's called, evaporation. Right? So it's a cooling process. On the other hand, condensation, which also happens in nature, is a warming process. Right? And energy is actually released when water changes from vapor to liquid. Right? Like I showed you before, but in nature, whenever we have this process going on, when the water vapor that we have up in the air begins to convert into water, a process called condensation, the result is that things around it get warmer because heat is released, latent heat is released. So evaporation is a cooling process, condensation is a warming process. So whenever condensation happens, which is what happens when clouds are created, heat is released. It's not like, all of a sudden it's going to go from 70 to 90 degrees, but there's a considerable change in the temperature when that happens. Again, we call that latent heat. The heat that is being released, right, by converting from water vapor into liquid, it warms the air around it. Now, water vapor, basically, we see it all over the place. We don't smell it. It's not visible. I mean, we don't see it. Some days you can see a really thick amount of water vapor when it's very humid out. Sometimes you can actually kind of see like a mist, right? Especially here that we're near the ocean. Sometimes we see that a lot. That you can see a mist sort of floating around the air, but for the most part, it's invisible, and you don't smell it. Now, this water vapor actually mixes with a lot of other gases as well. But anyway, so that's water vapor. Remember that when we talk about the atmosphere, one of those gases that varies is not constant. It's not, it varies from one day to another one. It varies from places to places. Some places around the world that are very dry have very little water vapor around at any given time. Others are constantly full with water vapor. That's a lot of moisture up in the air. But later it's called humidity, right? So we can feel it when the humidity is high. I mean, there's a lot of water vapor up in the air, right? And we can feel that. And again, we'll talk a little more about what humidity. Now, of course, that energy that is usually released when condensation happens, or it gets moved around by the wind. That's the reason why it's not always the same. Wind makes it change. It goes from it was very humid 3 hours ago. When the sun came up, wind began to blow. It blew it away. It's changing. Atmospheric moisture, the amount of vapor that we have up in the air, is not constant. It's not, the amounts are not always the same. It varies from day to day, from place to place. So I'm gonna I'll put a question out, and you can kind of answer that on the chat. Everybody's kind of participating that way, perhaps. Okay, so we're gonna talk about humidity in a minute here, but can people feel humidity?
Yes.
Again, you can answer on the chat. And if you want, maybe you can write something up about how does it feel, right? How do you feel humidity? Like I'm gonna explain humidity in a minute here. I want you to kind of start thinking about that. And again, you can type your questions. I know that some of you are on the phone. It might be more difficult to do that, but I mean, I see you guys. I see some of you guys, uh, you know, type in your when you're sending text messages. So I don't think I can't do it like the way you guys do it, but I know some of you can type pretty fast as well in your phone if you are watching this on the phone. Anyway, so I put the question up there: can humidity be felt? Can you feel humidity?
Yes.
We'll get back to that later on. Okay, so put your answers up there, or if you have any other questions related to that, put them. What is humidity? Again, use the chat to type some questions. I don't see anybody typing that, but I know if this was a chat room in Facebook on Snapchat or something else, I know you'll be typing like crazy right now. But anyway, all right. So let's talk about humidity. So humidity is the amount of water vapor that we have in the air. It's simple as that. Simple, but a little more complex than that. Right? So water, the amount of water that we have in the air is called humidity. Now, if you look at the chart that I just posted on the right, kind of analyze it briefly, and I'm going to talk a little bit about it. There's a relationship between what we call water vapor capacity and temperature. Right? You can see on the left, you have what they call specific humidity, saturation specific humidity. That amount can be measured. We can measure the amount of vapor that we have up in the air literally by weighing it. We can estimate a weight. You know, if you remember some of your conversions in high school and so on, we can weigh liquids, right? We can look at the volume and then find a weight to it. You know, so that can be weighed. But what you can see in this chart is that the amount of humidity is going to vary based on temperature. Right? The higher the temperature is. Now here's something I want to explain, and I want to be very careful. Those of you, some of you, and I'm not sure how you guys are doing the lab. I know that there's a few of you that were taking lab. I know I feel for a lot of my colleagues that are teaching lab, but I wasn't teaching. I'm not teaching a lab this semester, so it's crazy. I don't know how they're doing it. And I know there's ways to do it. We've been interacting with a lot of people that are teaching lab right now, and it's got to be real complicated. I mean, you know, physical geography is actually probably one of the easiest ones to do online. But imagine having to do a chemistry lab. I don't know if any of you are taking chemistry, but I cannot imagine how you can do, especially what they call wet labs. We actually have to mix substances and all that. I mean, a lot of them are just, you know, creating videos and showing that. But anyway, so that amount can be measured, right? Now, what you see on the red on this chart, where you see the red line that you see there, okay, it's called water vapor capacity. Right? Now, and here's one, you know, you guys know, I probably remember that I speak with my hands, so it's kind of hard, you know, with screen. I should have a screen that just shows my hand. Anyway, but anyway, so we can look at the air, at this vast amount of air that we have in the world. We can pretend that is, say, a bucket. Okay, they can be filled in with water, or you can lose some of that. It's not, right? It's not like that. One way to explain water, what we call water capacity of the air. This is what we're talking about, the air. The air has a capacity to hold so much water, only so much water. Right? So now that usually related to temperature. Right? The higher the temperature is, right, the more capacity, like the chart shows over here, the more capacity there is to add water. Yeah, and so if you have a bucket, right, the higher the temperature is, the emptier the bucket is going to be. I mean, if it's empty, that means you have more room to add water to it. Right? But if it's full, which is usually going to happen at low temperatures, right? That bucket can fill up, and it can become saturated. So, so we call this water capacity is the maximum amount of water that is possible for the air to hold at different temperatures. Again, let's say on this bucket, 70 degrees, again, I'm making things up here, but let's say at 70 degrees, it can hold 2/3 of the bucket. It will have water, or usually actually going to be less. It's going to be about 1/3. So the higher the temperature is, the warmer it is, the more capacity of the air to hold water, to add more water to it. But that means that it's drier, right? It's not as humid. Now, if you look at the chart way at the bottom at lower temperatures, the bucket is almost empty. So it has a lot of water capacity. When it's the opposite. When it's down here, when it's a really low temperature, there's very little capacity. That means the bucket is almost full. That means it's very humid. So there's basically that correlation. I'm going to put the temperature thing in here, just the fact that you're adding water to it is going to change the pressure, but it's not that much. So it's almost, I probably should take it out. But the pressure, atmospheric pressure changes very slightly when you add water to the atmosphere. I mean, you're adding weight. Remember, air weighs as weight, as a mass. So when that air begins to, you add water to it, the pressure begins to get a little higher. But it's very little, it doesn't change that much. But this is what is important to know. The warmer the air, the higher the capacity of the atmosphere to hold water. So, and I should put it probably in a different way. I'm going to explain relative humidity in a minute here. But if it's really warm, right, that means that it's going to be less humid. It's not going to be as humid. If it's really cool, the cooler the temperature is, chances are the humidity is going to be higher because the air is almost full of water. Now we're going to understand what happens after it gets full. Again, this mythical bucket that I'm talking about here. Once that bucket gets full, it's going to be a temperature when that's going to happen. Right? When that happens, the air is going to become saturated. Saturation usually will lead to rain. Right? It's not that the way it happens, but again, you can pretend this bucket, once it gets full, at some point it's going to start spilling the water. And that, in a very, very simplistic way, that's what happens when rain happens. Right? So just remember this, right? The higher the temperature, the warmer the air is, right? The less humid it's going to be, the less water that the air is going to have. The cooler the temperature, right, the more humidity. That means that the more water is going to be up in there, more water vapor is going to be up in the air. Okay. Try not to make it complicated, but that's how it works. It's physics. Right? Now, here's what happens with relative humidity. Relative humidity is defined as how much water vapor is in the air relative to water vapor capacity. That's why I had to explain water capacity earlier, because it is a percentage. It is a proportion, right? How much water you have in the air relative to how much you have the potential to add to it. Right? It is dependent on temperature, like I explained, and it has a formula. And those of you who are going to in the lab, you're going to be doing this if you haven't done it already, right? Relative humidity is defined. The formula is basically specific humidity, which is the actual amount of water that you have in the air, right? To the amount of water that the air has capacity to add. You know how that works? And you can put it up in this way out there. So relative humidity is the actual water that you have up in the air, water vapor in the air, divided by the capacity of the air to hold water. And the bucket that I was talking about, all that is multiplied by 100, which actually gives you a percentage, right? So relative humidity is always explained as a percentage, and it comes from this formula right here. The one you see right here, that one. So relative humidity, actual water vapor that you have in the air, the amount that you actually have, water that you have in the air, divided by the potential, the capacity of the air has to add more water, multiplied by 100. I'm going to put other questions that you guys can start typing up there in the chat. How many of you have heard of relative humidity? And let me see. I'm really a bad type. I type very bad. So I have to always correct myself. So have anybody heard of relative humidity? And why do meteorologists use that to determine whether it may rain? And I type horribly, so and my spelling, yeah. So the question is, has anyone heard of relative humidity, and why is it that meteorologists use that to determine whether it may rain? You know, why do they, like if you listen to the news, and I know some of you do, some of you don't, maybe nowadays that, you know, you are at home, maybe you watch it somewhere. I mean, I watch it, but I just try to avoid Trump anyway. So why is it that it's so important? So here's what happens. Here's what I see somebody sketching. I'm supposed to be able to share. I saw somebody was sketching out there, you know. Anyway. Okay. All right. So anyway, so has anybody give me the answer for that yet? So why is it that why is it so important to talk about specific humidity? Nobody's answering. Everybody's asleep or something. I should probably force everybody to put their faces out there so I can see who's sleeping.
No clue.
Or who's not even in nearby. I know that people just go out and do something else anyway. But so anyway, humidity is what the meteorologists talk about when they talk about relative humidity. Right? They sometimes they will say humidity is at 75%. And so what that means is that the air is not holding 75% of the water vapor that it can actually hold, based on the whatever temperature we have at the time. So so again, the meteorologist will say temperature right now is such and such, humidity is at 75%. Now the reason that is important to understand how it relates to rain, right? Is because a high relative humidity means there's less evaporation happening. Remember, is evaporation, the opposite of condensation. When you have a higher relative humidity, that means that the air is getting close to being saturated. When the air is saturated, that's when you have 100% relative humidity. When they're then clouds are going to begin to get created because there is the bucket, you know, that I was telling you about, the air that is this bucket is not full. It's a capacity. When the air is a capacity, right, it's saturated. It can no longer hold any more water. And at that point, condensation is going to begin. Again, in a very simplistic way that I was explaining before, the bucket is water. Right? Not what is actually happening, but you can look at it that way. So again, when the meteorologist talks about humidity such percent, remember it changes from day to day. I'll show you some maps in a second. It changes from day to day, and it also changes from location to location. Right? It changes in season, right? In the summer, we're going to have very little humidity as opposed to right now. That is, especially these last few days that have been very cloudy and all that, humidity is going to go up. So when there's a capacity, when the air is saturated, means the same thing, or when it's 100% humidity, right? Condensation is likely to occur, which means that clouds and fog are going to be created. Usually clouds is what we're concerned with here. Right? So again, what happens is when you reach saturation, 100% humidity, right? The air, now the water vapor, that is the air, right? Slowly now begin as, there you go. It slowly now so you guys seeing the screen now? Yes? Is that very,
Yes.
yeah. Somehow I think we got, anyway. All right, so when the air is again, the higher the relative humidity, the less about it's impossible. But when air is saturated, it's 100% humidity. The air is a capacity. That means condensation is likely to occur. Clouds are going to be created. Now, having clouds doesn't necessarily mean that it's going to rain, right? But it's likely. It increases the chances of precipitation occurring, rain happening. You can't have rain without clouds, right? So you need to have condensation to occur, so clouds can get created, and then so the rain may happen. So that's why the meteorologists talked about this. The meteorologists will tell you humidity is at 75%. That means it's very close to being saturated. When it's 100%, then it's saturated, and it's likely to have rain. So that's how meteorologists uses humidity to sort of give you the possibility of rain. The higher it is, the higher the humidity, the more chances that cloud will be created and rain will actually happen. That make sense?
Yes.
Yes.
Only two people are awake, right? Anyway, we'll see.
We are awake.
Well, and they're not saying, not saying anything. I know some of you are, and I can see some of you out there. But there's a lot of people that just kind of, whatever, Yeah, this is of course one of the issues with these live lectures. Some professors are complaining that everybody doesn't put their face out. I mean, not that I love to see your faces again, but sometimes when I'm talking, I can tell who's actually paying attention, who's not. Or I remember some of you guys were passing notes to each other, and you kind of just face out. But I can't do that here, so it's really hard. So, like you say, one way you can tell me is by typing things out. Remember, you can create a record of this. If you have a question that you maybe in the regular classroom you wouldn't voice, you wouldn't tell me in class because you were embarrassed or whatever reason, you can do it here. Just type it out. I don't understand what you mean by this. And again, if I don't get to the answer to the question right now because I'm really bad typer, I download the record, I download the chat. I can post answers to questions that people put out. But I need to know some way that people are awake and they're paying attention, and or but otherwise I'm just gonna keep talking. If nobody says anything, well, I guess you understand it, right? Like I say, without being able to see your body language, I can't determine whether you are getting it or not. Okay, this is relative humidity, right? So here's what happens. Has anybody been to, you can type your answer here on the chat. Has anybody been to say the Miami or the South or Florida or even Mexico, maybe down some areas down around the tropical regions of Mexico, and felt the humidity? Has anybody felt that?
Yes.
Been
And
to Florida, and the community there is horrible.
exactly, yeah. So what is the connection between how it feels on a very humid day and a dry one? So all the stuff I just talked about is actually related to relative humidity. Remember, relative humidity is the amount of vapor, amount of water that we have in the air. So, here you go. So why is it that on a humid day it feels hotter than on a dry? So let's say we are in Miami, Florida, and let's say 90 degrees temperature. And we also in Phoenix, Arizona, it's also 90 degrees. Now, right, even without looking at the humidity level for that day, I can assure you that Florida is going to be a lot more humid, right, than it is Phoenix. Phoenix is a lot drier just in normal circumstances. So here's the day. We have two places, one in Florida and one in Phoenix, Arizona, both are 90 degrees temperature. So why is it that it feels hotter in Miami, Florida than it does in Phoenix?
Isn't it because of the amount of water vapor in there?
Exactly. It's exactly what we were just talking about. But here's why. And I'm going to tell you the reasons, and then we can talk a little more. And I'm going to put them all down here. I'm going to go through each one of them. Remember how I said that evaporation is the way that our body cools itself? Remember that?
Mm-hmm.
So basically, when it's hot, let's say 90 degrees at both places, the body's going to start sweating. That's the way the body's trying to cool itself. So when it's too hot, it's going to start evaporating. We're going to start sweating. When we sweat, right, in dry air, say when we sweat in Phoenix, we have very little humidity. That area, that evaporation is eventually going to join the atmosphere. That goes somewhere. It doesn't just die. It doesn't disappear. So because Phoenix, Arizona is dry, that means it has less capacity, right? It has a lot of capacity. It's dry. The bucket is not full, right? So you can add water to it. So the water that is coming out from our body is actually going up into the atmosphere. And because it's a lot of room, right, you're just going to go up there. It's going to leave our body. You're going to sweat. You're going to cool off. And the water vapor that is coming out of our body is going to go up into the atmosphere. But when you're in Phoenix, when you're in Miami, Florida, when the humidity is near, remember, it's like say 90% humidity is near capacity. There's very little room for that evaporation in our body to go up into the atmosphere. So in Miami, Florida, you're sweating. That water is not going anywhere. Where is it going to stay? It's stay in your body, right? So that's why it's going to feel all sticky, and it's going to be hard because again, you're not sweating as much, and whatever you sweat is going to stick to your body. It's because it's not going up into the atmosphere. There's no room up there. When you're 95% humidity, the bucket is full. You can throw very little water out there. Whereas in Phoenix, Arizona, right? In Phoenix, Arizona, lots of room. So the water vapor that comes out of your body is going to go up. That makes sense? Someone saying
Yes.
the sugar evaporates.
Yes.
No, no. Remember the temperature in both Phoenix and Miami are 90 degrees. The temperature is the same, but it's hot. So it's just so your body still reacts the same way. Your body still sweats because it's trying to cool off because it's hot. But the difference is that if you have a high humidity, like you do in Miami, that vapor is coming out of your body, that's sweat is, evaporating. All that evaporation it doesn't have any room to go up in Miami, but it can go. It can leave your body and then join the rest of the atmosphere because it's a lot of room. And so that's why it happened. So that's why it feels a lot hotter, even though the temperature is the same. But one of them is more humid because the water vapor is coming off your body, it cannot go anywhere. All right. Anyway, so again, if you have any questions on that, now you know. So when you go to Cancun, you go to Acapulco, whatever, that is usually more humid down there. You're gonna see why it's so uncomfortable. Your body, the heat from your body is not evaporating; it's staying in your body. Anyway, so it looks like I'm gonna stop it right here in terms of the content. Let me finish really quick here. Now, let me stop. Okay. Okay, so you should see my face now, right?
Yes.
See my face? Yes? Not yet.
Yes. Mhm.
Well, now we see the screen.
Now you see my face?
The
Yes, on the
screen.
right hand side, yes.
Hold on, let me make sure that I got the right screen here.
We can see both. So you on the screen.
Do you see my face now?
Yes.
Okay. I don't know why I'm not. I mean, it's so much stuff to learn in terms of the setting. Now, is anyone who's here who has not, remember some of you, I give you a chance to submit your, uh, to submit your, uh, to submit uh, extra credit thing for the exam. Again, you can write that in the. I'm still learning a lot of these things. There it is. Okay. So if you are one of those people who want to get some credit on that, you need to stick around. The class is going to end in 1 minute, and then you're gonna have to turn your camera on, and you're gonna have to show me that. Let me put the shot up here. Anyone who, I know some of you probably forgot, I don't know where you're talking about it anymore, but if you are one of those people, then you need to stick around and then literally show me your work so I can give you a little bit of credit. Remember, I'm not gonna give you full credit. Those of you who submitted stuff on time, who were there that day when I issued that stuff out, I got the credit they deserve. Remember, it was prorated. You were not getting automatically 25 points. You're getting whatever grade you got in the exam, and also whether you complete the stuff up. I also said that I was not going to give you partial credit, but I still did some. If you didn't answer the question, you're not going to get full credit. So, is there anyone here? You can send me the shot. Is anyone here? Again, you need to stick around. I'm gonna end this in a second here. But if you are one of the people who needs to show me their extra credit stuff, stick around. Literally, you're gonna have to just put it in front of the camera, show it to me, and once you do that, and what I'm doing this also, let me make sure I take roll. I don't think everybody was here today. You know, and I know you have all the classes too. Are people dropping? You know, are people dropping the classes and stuff like that? Do you know anything like that? You know anybody who, like maybe you had in your class that is not? Because I see we have a lot of people who are not here today. I don't know why. So let me make sure that I gave credit for everybody who's here today. Yes. Let's see. So for 1 second so I can give you credit. Dominguez. Alejandra, did that make sense? Again, you came up if you want, but did it make sense? Can you ask me a question? You send an email about photos. Does that make sense? Hold on. I'm just trying to finish up roll here and I'll get back. And, hey, guys, I'm talking to take roll here now. And, okay. So let me ask, I guess I'm not sure if I don't see Gabriel and if you're here, you need to, I have the entire list in front of me. I don't see. No, Felipe Avila, Agustina Viles, I don't see you. Yeah, there's other two that they already disappeared. Yeah, it's here. Daniela Perez, I guess she's gonna go desaparecido. Lisa Ramirez, I don't see you here. And Abla Ruiz, if you're here, you need to pick up now because I don't see you on the list. And Leslie Velasquez. Okay, so that looks like it's about it. Well, you guys, so anyway, so okay, so those again who want to get that credit, you can stick around so I can show me that. I see a couple of questions from okay, yeah, thank you, Alejandra. And then I think somebody's asking about difference between humidity and evaporation. And thank you, John. I think you answered it a little bit there. But yeah, so the difference is the humidity is the amount of water. Remember, I show you a formula. It's a formula that is like a proportion between the amount of water that you have in the atmosphere relative to the amount that is available that is space for. Right? So the ratio is a percentage, right? So you're saying I have this much water in the air based on the amount that it still has room for. So again, it's a proportion. Whereas evaporation is remember, evaporation is a process. Is the phase of water changing from, in this case, for evaporation from liquid into into gas. So that's how basically all that atmosphere that we have, all that humidity, all that water that we have up in the air goes up that way. Is created by evaporation. That makes sense, Andrea? And, anyway. Okay, so all right, so again, those of you, I think I don't know how many of you are there. So the rest of you, did that make sense, Andrea? Thank you. Yeah. So so those of you who wanted to submit something, I just have to show it to me. Otherwise, basically classes is missed. I'm already taking roll. We'll be seeing you on Tuesday, again, same time. You guys, I know some people were wondering why don't we change the time? I don't want to get up at 8 in the morning. Well, I don't need it, but they don't want us to change it because some of you have other classes and they don't want to interfere with that. Because if I start saying, oh, let's meet at 10, and, you know, some of them may have a class then, and they don't want us to do that. They just told us specifically that we need to keep the same time that we had to avoid conflict with other classes. That makes sense?
Yes.
Yes.
Yeah.
All right, you guys. So again, everybody else is dismissed. Don't forget the assignments that I do this weekend. Remember the photo essay. Use a picture that you have before, or take one from the web, and you can just put it in. As long as everything remains the same, except the only thing that is acceptable now is you don't have to take the pictures yourself. You still have to represent them and so on. All right. Any
Okay.
questions? Again, those of you who want to need to show me their revisions of the test, you can stick around so I can go through that. The rest of you, I already pretty much give you whatever credit you had at that time. And anyway, okay. See you guys
Okay.
Tuesday. Have a nice weekend. Stay safe. Wash your hands. Help out your elderlies if you bring food and all that, and take care of yourself. All right. Okay.
Okay, take care, teacher.
Okay.
Thank you.
You guys, again, those of you who stick around, show me what you have, and then I'll give you credit for whatever you have. Okay, so that means if you Garcia, you have some?
Yes.
Just go ahead and show it to me. Let's see if I can. So those are the matchings, right?
Yes, doesn't matching one.
And how about the multiple choices? You have to fill in the spaces on that. Okay. All right. So yeah. So like I said, you'll get some credit. I have got the score. Remember, it's going to be based on the score that you got on the exam, and then because it's kind of late, we're not going to give you the full point, but you get some
I
extra.
understand.
All right. Okay. Thank you, Juan. Got it.
No problem. Have a good weekend.
You want to show me?
Yeah, I also got mine.
You already done it, right?
And it's from exam 1. What? Hello?
Who has some revisions that want to show me?
I do.
You have some? Go ahead, John. Just you got to
Yeah, do I just...
turn the camera. All right. So those are your multiple choices, right? Okay. Just
Yeah, I didn't get any of the word ones wrong. It was just like not the matching questions. I just got like 6 problems wrong. And I like answered them.
yeah. So remember, you have to answer the ones that you got wrong, right?
Yeah, I did.
Yeah. Okay. That looks good. Yeah. And you didn't get any wrong on the matching questions.
No, just these
Fine,
6.
So I'll go ahead again. Based on your score that you got on the.
I have a question. Can you hear me?
Yes.
What about the photo?
Is this
essay? What do you say?
Is
About
it statement?
was acceptable? Can we use
Who's
any
talking right
topic?
now? But I don't see a video, and or is it Eric or Kevin who's talking?
Kevin.
Okay, you want to put your camera on? You know how to do that?
Uh,
You can unmute it. So click on the image that you see there for me, and then just there's gonna be, if you click on the picture, there will be so you can mute or unmute. If I try to see if I can unmute you. Yeah, but you have to anyway. So go ahead and answer the question, because I can't see anything. If you don't, you have the camera on, I can't see what you submitted. So what was your question?
about the photo essay.
About the what? Photo essay.
The
Go ahead.
photo, yeah. So can we use any topic right now, or
Can you use any? I didn't quite hear.
okay? I'm gonna use the chat.
No, so okay, so you said, can you use? What about the photo essay that you need to know?
He asked if he can use any topic.
Any pictures?
Yes.
Yeah, you can use, like I say, you can go on the internet and find pictures. They don't have to be necessarily taken by you, because again, you guys can, we're not supposed to go out, right? So, but again, they still have to match with the concept. So let's say go to National Geographic and you find a nice picture of I don't know, something that's representing snow or something that's representing humidity is really hard to describe, but maybe something about water. Maybe you go to a lake and or took a picture of a lake that you like or whatever, right? Or permafrost or something like that. So you are now able to use pictures that are not necessarily taken by you, right? But they have to be, the concepts still have to be defined accurately. So whatever picture you put up, whatever you got it, right? Make sure that you're still using the right concept, a physical geography concept to define that concept. And then in the place where it says, where do you take the picture? When do you take it? You just have to tell me where you got the picture, right? Got it from
Okay. Okay.
or something like that. That makes sense?
Yeah. Thank you.
All right. Anybody else has another question? Eric, you have a question? I see you still there, maybe. All right. John, you had another question?
No, that's it.
Okay,
I'm
all
ready
right.
to go.
You
Okay.
should be all set.
Okay, cool. Thank you.
Thank you. Have a good day, guys.
See you.
All right, we'll see you Tuesday, man. Take care. Eric, you had a question as well? I still see you out there. No? All right, I guess you're not there. All right, guys, so I'm gonna end up the class. All right, I'll see you guys Tuesday.